That's okay. All right. So let Pinakini also join.
I think sometime we'll go through the video, man, but it's 2 hours. That's a
It's like
problem.
we can watch it like a movie, maybe.
Yeah, we can, few places we can actually skip it.
Okay.
I don't think so. I'm explaining. I'm justifying whatever I'm
Come,
explaining. So
come on, man. You're doing a good job. Okay. So we are able to understand things. Okay. Start to speak about these things now. So
yeah, Pinakini was asking about normalization. Pinakini, I also don't remember exactly how it is done.
what is
Okay,
soft? Is it normalization thing or something else?
normalization. Yeah, I
So
mean it
some
is a simple thing.
algorithms which are already there, we use them to basically normalize, right? So, I mean,
Yeah,
so
I think there.
normalization we have to do anyways, and
Uh,
something whichever is available out there, I mean, it's mandatory or it is like part of all these things to normalize basically. That's like a basic thing or something that is
you can
standard.
think like that. It is part of it to normalize. I think these libraries only will normalize.
Okay, but that is compulsory. Like in the usual flow, we have to do it, right?
Yeah.
Okay, okay.
So just to kind of reiterate the flow, just to make sure we fill the gaps. So we have natural language, which are words. We use tokenizer to tokenize them into tokens and to get the tokens. Then we vectorize those tokens to get the vectors. Vectors can be they are multidimensional vectors, okay. Depending upon which embedding model we use, we get that dimensional vectors, right? And then we flatten those vectors. Then we normalize those vectors, we flatten those vectors. Then we pass on to the feed forward network for the neurons to get trained on those numbers, right? That is what it is.
Yeah. Yeah. Yes.
Okay, we can take it for further later, maybe. Yeah. Okay. So you were saying something else?
No, no. I think we are actually um, trying to uh, jump also in between. So maybe few things becomes complex. Okay, because I suddenly jumped into that multi-layer neurons, right? Um, so yeah, I was trying to say that okay, it's it's a bit of mixing we are actually. So it might go here and there.
That's fine. I mean, uh, whatever questions are coming to our minds, right? We follow.
But I think we should take a note of all the questions, Vinal. If we
I
can take a note and then we can come and discuss that, right?
yes, yes.
That will that will clarify a lot of things, even for me.
Yeah, I'll pose the
Yeah, that
questions.
is a
Okay.
good idea, actually. Yeah, yeah. We should do
No,
that.
any questions, any simple questions, anything,
Yeah.
right? We should discuss that.
Sure, sure. This session's questions, I'll send it across in WhatsApp, okay, and upload
Yeah,
I
yeah.
uploaded the videos till before the last session. So last session's videos, one video is with Arun, one is with Pawan. So you guys send me across over WhatsApp or however you feel like it. I'll upload it to
No,
YouTube.
if you have a Google Drive, you give me the access,
Yes,
man.
I
I'll
can
upload it directly to that.
I can do that. I can do that. All right. So Pawan, going back to the slide, you want to wrap up?
No, man.
Don't want to wrap up
Yeah.
or what?
Uh, I don't know. You wrap up, man. We
No, I
What
mean,
did we do?
uh,
Yeah, we talked mostly about the perceptron only today. How it yeah, it represents the line, and then how it can classify the different set of outputs like 1 and 0 using that line, and perceptron is having the two parts actually, summarization and the activation function. So activation function is where we say that the neuron or perceptron fires, like when it is one, it's we say fired. Okay. What else? Yeah, that's it, right? We didn't talk anything different today.
Yeah. And if we have something like, I mean, each perceptron is solving a linear
Correct.
problem. And if you have a complex problem like the XOR gate, if you want to recall, which uses two
Right, right.
perceptron.
Yeah, we didn't discuss that, but yeah, this NAND, NOT gate, AND gate, I think even NAND gate, all these things are linear problems. So you can use only single perceptron to solve this. But say XOR output is a different case. Okay, you cannot solve that one with the linear problem, a linear, sorry,
One percent.
with the single perceptron.
Yeah.
See, if the XOR is like this, so your output is 0 here and 0 here and 1 here and 1 here. So you can't use a single perceptron or the single line to classify this, right?
Hmm.
So you need multiple perceptrons here that we can see next time, next session. I mean, we have already discussed that, but we can go over it again.
Yeah. This is still solving a problem using the two perceptrons. Fine. And
Yeah, you need minimum two perceptron. Like you see here, the two lines, right? So you need two plus one perceptron actually. Total three perceptrons you need.
correct. Okay. Next diagram, next slide, you can show the why it needs three
Yeah,
percent.
this is three perceptron. It solves the XOR problem.
All right.
So the idea is like this. Okay, um, you have one perceptron, you represent one line. You have two perceptron, you represent two lines. Um, um,
What if you have a quadratic equation like a parabola, an elliptical
hmm.
line,
So
exponential line?
parabola and all, you have to say, you have, one second, say you have something like this. Okay. So how do you, something like this. So how do you do this? So you will have one line till here, one more straight line till here, one
Hmm.
more straight line till here. So now you calculate how many perceptrons is there. One line can be represented by one perceptron. Okay,
Right.
one line can be represented by one perceptron. So you do like that, and you solve this parable. Any this one, any you can solve anything in the world. I mean, you cannot solve. You can approximate the solution for any problem in the world using this deep neural networks or the deep neural networks. Um, so the deep neural networks is called or is the universal approximator.
Hmm. All right. So
Yeah,
I think we can wind up here, Pavan.
yeah, we can. Yes.
For next week, we'll cover what topics or weekday or weekend, whatever.
Yeah, next week I'll be busy, I think. Next Sunday only I'll be available.
You have the Viva, right? Okay.
Yeah, I have the Viva, I have some other demo in office.
All right. Cool. Then Sunday, let it be Sunday.
Yeah.
And if we have to cover anything in the midweek to revise anything before, I can take up a session on fine tuning as well, because we did fine tuning part one in the last session. We can do fine tuning part two in the upcoming session, maybe, since yeah, that'll help to catch things faster in these sessions. That is training, right? So yeah.
Yeah.
All right. I'll post the
Yeah,
video.
send me the questions. Send me
I'll
the
post the
question.
videos. I'll send the summary in the YouTube channel only, and I'll send the questions in the WhatsApp group. So yeah, cool guys. I think we can wind up
Yeah,
now.
sure.
Yeah, thank you so much, Vinay
Alrighty.
and Pawan.
Yeah,
Thank
thank you
Thanks.
you.
guys for joining, everybody.
Bye.
Bye bye. Happy weekend.
Thank you. Bye. You too.